Assalamualaikum and hello. In this video, we are going to focus about how to explain the reactive sites and nucleophilic addition reaction for carbonyl compounds. For your information, both aldehydes and ketones can undergo nucleophilic addition. This is because of the presence of carbonyl group. So why this happen? And why C double bond O is more susceptible to nucleophilic addition? Let's try to understand from bits to bits. The first one, you have to know that carbonyl compounds are polar molecule. If I draw to you the structure for carbonyl group in a compound, we will have carbon bonded to oxygen with 4 covalent bonds. And if you see here, there is a difference between carbon atom and oxygen atom for electronegativity. And it means that oxygen atom is more electronegative than carbon atom. So oxygen will be partially negative, while carbon will be partially positive. And this case makes that the electron density is drawn more towards oxygen atom, making carbon atom has less electron density. So that's why if I have my nucleophile Nu minus with negative charge, so my nucleophile, which can be any species with higher electron density, will attack the area in carbonyl compound, specifically at the area which less electron. So carbon will be the choice. So nucleophile will attack from negative charge to carbon. And this is why we call it as carbon becomes the site for nucleophile attack. Next one, once the carbon atom in carbonyl compound is attacked by nucleophile, the pi bond here, which is in this case, you got double bond. The first one is sigma bond and the second one is pi bond. So the pi bond here between carbon and oxygen atom will form tetrahedral intermediate, where the double bond itself will go towards oxygen atom. And your structure will be carbon with 4 covalent bonds, and oxygen will be O minus because it got more electron from pi bond that's been broken, and nucleophile will attach to this carbon from this attack. And once this tetrahedral intermediate form, the reaction will progress where you treat with H plus. This H plus will be attacked by O minus. So you will have OH here. So this is the reason how you want to explain why carbonyl compounds is more favored to do nucleophilic addition. For the next part, you have to understand as well about the reactivity for aldehydes and ketone. For carbonyl compounds, you know that we can choose between aldehydes and ketone. But in reaction of carbonyl compounds, the main fact is aldehydes are more reactive than ketone. This is the main fact. So why aldehyde is more reactive than ketone in addition reaction? There are due to 2 factors. The first one is steric factor, and the second one is electronic factor. I'm going to explain to you one by one. For steric factor, or the other name that you can call it as steric effect, you can see the difference between the structure for aldehyde and ketone. So I got aldehyde on my left and ketone on my right. If you see here, the difference between aldehyde and ketone is the presence of hydrogen atoms for aldehyde and the presence of another alkyl group for ketone. So if you see here, the size for hydrogen atom is much more smaller than alkyl group because this is atom and this is group. So when group, you can understand there will be a mix of another more than one atoms. So that's why for aldehyde, due to hydrogen attached to the carbonyl carbon, this make that aldehyde is less crowded, or what we call as less hindered than ketone. So the electron cloud in aldehyde is smaller than ketone. So this is about the size of hydrogen atoms compared to the alkyl group for steric effect. Now we go for the electronic factor or electronic effect. So as you see here, both aldehydes and ketone got carbonyl group. Here, the one that I highlight as the purple one. So if you see here, I'm going to introduce to you two terms. The first one is electron withdrawing group. So this is the short form for EWG. And another term is electron donating group. The short form is EDG. So for your information, hydrogen is electron withdrawing group, while alkyl group is electron donating group. So what does it mean by this term? If you see here, ketone got two alkyl groups at carbonyl carbon. The carbonyl carbon here is electron deficient and electrophilic, since the neighboring oxygen atom has a greater share of electrons in the double bond. However, when you have neighboring alkyl groups here, these neighboring alkyl groups here have inductive effect, whereby they push the electron density towards the carbonyl carbon and make it less electrophilic and less reactive to nucleophile. So that's why, compared to aldehyde with one alkyl groups only, it will go towards this direction. And for aldehyde, we got another one more special thing for hydrogen. So it will go towards that direction. And this is making aldehyde is more electrophilic and more reactive to nucleophile compared to ketone. So I hope all of you understand how to explain why carbonic compounds is more susceptible to do the nucleophilic addition, and another thing, how you want to describe the fact that aldehydes are more reactive than ketone in nucleophilic reaction. Only two factors that play the role here. So I hope you understand about this video. I will continue for the next one in the next video. Thanks for watching. Bye.